Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you all doing well. Dear students, this lecture is for grade 9, subject chemistry. In this lecture, we will do exercise of chapter number 8, the remaining parts. This is my 32nd lecture, and I am your lecturer, Mrs. Saira Jamal. Today we are going to do question number 6, extended question answers. Give some important applications of platinum. Platinum is widely used as a catalyst for many types of industrial processes. You know that catalysts are the compound or the substances which speed up a chemical reaction, same like their function is the enzymes, which are biological catalysts. For example, 100% pure sulfuric acid is prepared in the prepared in industries by a process called contact process. In this process, platinum is used as a catalyst. Platinum is also used as electrode as a part of hydrogen electrode and in fuel cells. Automobile exhaust is a major source of air pollution. Therefore, most new cars are equipped with a special type of instrument which is called or equipment which is called catalytic converter. These converters contain platinum as a catalyst, and the function of these converters are that they can convert the harmful gases into non-harmful gases. They convert carbon monoxide after complete combustion into carbon dioxide and all the other hazardous gases into non-hazardous gases. A platinum compound called cisplatin is useful as an anti-cancer agent. It is used as an anti-cancer agent. So the first use of platinum is it is used as a catalyst in industrial processes, especially for the production of or preparation of sulfuric acid by contact process. Secondly, it is used as an electrode in the hydrogen electrode, and also it is used in fuel cells and in automobile exhaust, as I told you, in catalytic converter, which is an equipment used in the automobile's engine, which is fitted in automobile engines, and that catalytic converter convert the harmful gases into non-harmful gases. And fourth application is that a platinum compound called cisplatin is useful as an anti-cancer agent. So there are these four important uses of platinum. You can see in this image, this is the platinum, and uses I told you as it is also used in jewelry, in making wires, electrical contacts, and also laboratory vessels are prepared from platinum. Expensive watches, because platinum you know is stable metal, and it does not tarnish or wear out after rough use. Electrodes are also used of platinum, and it is used to coat missile nose cones, jet engine fuel nozzles, and other devices as well. Electrical furnaces are also made up of platinum. I told you in jewelry, platinum is also used in jewelry, in watches, etc. Because I told you it retains its brightness, it resists corrosion, and it is heavier than jewelry made from other precious metal. This is the catalytic converter, which I told you is fitted in the automobile engine, which convert the harmful gases into non-harmful gases, and the platinum is used as a catalyst in it. Along with other catalysts, platinum is also used. Question number 7, identify the position of potassium and calcium in the periodic table. Potassium is present in group number 1A and known as alkali metal, and it has general electronic configuration NS1. And calcium is present in group number 2A of the periodic table. It is also called alkaline earth metal, and it has general electronic configuration NS2 in its valence shell. Question number 8, what is aqua regia? Aqua regia is also called royal water. Gold and platinum react only with aqua regia. I told you gold and platinum are called noble metal. They does not react with any acid or with any base or with any oxidizing agent. They only react with a special type of solution called aqua regia. Aqua regia is a mixture of 3 parts by volume of concentrated HCl and 1 part by volume of concentrated nitric acid, and it is also called royal water. You can see in this image, this is the aqua regia, which is used for the solution for the solubility of gold and platinum. Aqua regia. Think tank question number 1. Why is it advisable not to pick sodium metal with finger? Sodium group number 1, alkali metals are highly reactive. They react violently with water, especially moisture of fingers, and often they explode. And this reaction produces sodium hydroxide and a strong base called caustic soda. So caustic soda and the hydrogen gas which is produced, it produces with a small explosion or a light explosion, and that explosion may be damage our skin or our face or the part which come in contact with the hydrogen gas. Question number 2. Arrange the following element in order of increasing non-metallic character. Silicon, aluminium, and phosphorus, they all lies in period number 3. And you know that when we are going from left to right, the non-metallic character increases. So silicon is group number 4, aluminium 3, and phosphorus is present in group number 5. So this is aluminum first, group number 3, then 4, and then 5. As along the period when we go from left to right, non-metallic character increases. So phosphorus has the more non-metallic character as compared to silicon, and silicon has more non-metallic character than aluminum. You can see this is sodium. Sodium, I told you, is a metal, but it is as soft that we can easily cut it with a knife. And we are not using sodium with the finger because it reacts with the moisture of our finger, and it produces a product, hydrogen gas and caustic soda, sodium hydroxide. But the reaction is highly exothermic, and if it come in contact with the moisture, a light explosion takes place which may damage our skin. Question number 3, design an experiment to show that iron is more reactive than copper. For this reaction, we use 2 test tubes. In one test tube, we will use copper sulfate solution, and we will hang an iron nail in copper sulfate solution. And after some time, you will see that the iron nail become brownish in color, and the color of the copper sulfate, you can see it changes or it decolorizes. It means that the copper sulfate solution is converted into iron sulfate solution, which is, you can see, the brownish in color. And iron sulfate solution, the copper sulfate, which were initially blue in color, the copper is displaced by iron, which show that iron is more active than copper, and iron can displace copper from its solution. So you can see that the iron is displaced by copper. Now the iron nail converted into copper wire, and the copper sulfate solution is converted into iron sulfate solution. So this confirms that iron is more active or more reactive than copper. Then question number 4, design an experiment to differentiate between chloride and an iodine. For this purpose, we need test tube, glass rod, and chemical like dilute sulfuric acid, concentrated sulfuric acid, ammonium hydroxide, and salts which contain chloride, iron, and iodine. Actually, these tests are for the salt analysis to identify the ions or the acidic radical in the salt. So we will take small quantity of each salt in separate test tube, and then we will add a few drops of dilute sulfuric acid, and we'll see what happens. If a gas evolve, test each gas, check the color of the gas, smell of the gas, and uh, take small quantity of remaining salt in dry test tube, and this time add few drops of concentrated sulfuric acid. If in the first case by adding dilute sulfuric acid nothing happened, then add concentrated sulfuric acid in the salt in separate test tube, and now analyze and also heat it and analyze what happened. Note the salt that give colorless gas having pungent means irritating odor. Test this gas with a glass or dip in ammonia or ammonium hydroxide solution. If it will give white fumes, it must be hydrochloric acid, means it contains chloride ion as an acidic radical. Yeah. Now question number 5, an iron bar is to be silver plated. Which metal would be the anode and which the cathode? I told you that the metal which we are going to electroplate, we will use that metal as the anode, and the one which we are the metal which we are electroplating, we will use that as a cathode. So as we are going to electroplate silver, silver on an iron bar. So that iron bar we will use as a cathode and the pure silver as a anode. What will happen? The anode will oxidizes, it will leave electrons on the electrode and will go down in the form of silver ion in solution. Those silver ion will then move towards the cathode, while the electrons will move to the external circuit from anode towards the cathode. When the electron reaches the cathode, the silver ions, as they are moving towards the cathode, they will take electrons from the cathode and then internally convert it into the silver metal, and that silver metal will electroplate or make a layer on the this iron. So this is called electroplating of silver on iron. In this image, you can also see this is a spoon, iron spoon, which is electroplated by the silver. That silver will go and electroplate this iron spoon. The method I told you is same. The spoon will act as a cathode and silver as an anode, and we will use the salt of same metal, silver nitrate, and the silver will loses electron on anode and come into the solution in the form of silver ion. Silver ion will move towards the cathode. Over there, the silver ion will get reduced by gaining electron, and then we'll convert it into the solid silver form or metal form. That metal will electroplate this spoon. Question number 6, compare corrosion of aluminum and iron. The corrosion resistance of aluminum is depending on the protective layer. I told you that on aluminum, a protective layer of aluminum oxide is formed. That is a tough coating. It protects the rest of the or the lower layer of aluminum from corrosion and prevent them from exposure into the atmosphere or into the air. And on the other hand, the layer of iron which is formed is ferric oxide with X water molecule, which is also called rust. That layer is porous and it is easily flaked away, and the inner iron come in contact with the atmosphere, and then in turn the corrosion of that layer also takes place. That's why iron is corroded more easily as compared to aluminum. The protective layer of aluminum is strong and tough layer. Then corrosion mechanism, I told you before that the coating of aluminum which is formed is that is the aluminum oxide, and that is a strong blister or a strong coating which prevent the rest of aluminum from corrosion. While in case of iron, I told you that is the rust, a ferric oxide with water. This layer which is formed is porous. It has pores, and due to those pores, the aluminum come in contact, the iron come in contact with the atmosphere, and then in turn, the process of corrosion continue because this layer flakes away. Then question number 7, compare and contrast alkali and alkaline earth metals. Alkali metals in both groups, activity is increases down the group. Like in alkali and alkaline earth metal, the reactivity of metal increases down the group and decreases from left to right. Both are isolated from their salt by electrolytic method. We can isolate them by a method called electrolytic method. Like we discussed that how can we extract sodium from sodium chloride, the down cell method, you remember. So that down cell method is actually an electrolytic method. They are silvery white metal. In flame, both group element give different colors to the flame. That is the flame test. Both group element are soluble in liquid ammonia and give deep blue solution. Both are present in S block. Both react with hydrogen and form hydrides. Both groups are differentiating on electron enter in S subshell, and then in S subshell, both group elements have electropositive character. As they are metals, or metals are electropositive in nature. Carbonate of alkali and alkali metals are soluble in water. They do not decompose on heating, while that of the alkaline earth metal are insoluble in water and decomposes on heating. Action on carbon do not directly combine with carbon. They directly combine with carbon and form carbides. Salt solubility, sulfate, phosphate, fluoride, chromate, oxide are soluble in water, while the salts of alkaline earth metal are insoluble in water. The reducing power of alkali metals are low and oxidation potential are high, while the ionization potential values are high and oxidation potential are low. Electronic configuration is NS1 for alkali metal and NS2 is for the alkaline earth metals. Question number 8, choose three metals that would not be suitable for making coins or for coinage. Group 1 elements and group 2 elements, they are highly reactive. So they are not good for making coins because they are highly reactive, they are water soluble, they are soft and they react with air and are totally unsuitable for coins. So group 1A and 2A elements are not good for making coins due to their highly reactivity. So dear students, this was all about the chapter number 8 exercise and think tank. Congratulations, the syllabus is completed. Wish you best of luck and try to learn all the chapters thoroughly, and they are very important, and inshallah you'll be able to appear in the examination with full preparation. Our prayers are with you. Take care. Allah Hafiz.